Welcome to Clojure Backtesting, a backtesting framework for quantitative investing and trading written in pure Clojure. First, we need to make sure your environment is properly set up to run this library. The requirements are listed out in the README file, and a good tutorial on installing them is linked with it. We recommend you use Java 8 or above and have Clojure and Lineagen installed. To verify your Java installation, you can run the command java-version on your terminal. Clojure Lineagen is an open-source build automation and dependency management tool for Clojure projects, primarily used to simplify the development process. It handles tasks such as downloading libraries, compiling code, and packaging applications for deployment. In Clojure development, Lineagen streamlines the workflow, making it easier for developers to build, test, and run their applications. To verify its installation, you can run line version. Here's the output: line 2.10 running on Java 20. Clojure and Lineagen are written on top of Java, so even when you're writing code with Clojure syntax, it gets compiled down to Java bytecode, which is why it's so fast. There are two main ways you can run programs. The first method is to use the line REPL. It's a simple interactive shell where you can execute code line by line. The pros of using the line REPL is that you don't need to install any external software or library as long as you have the previously mentioned requirements installed, which is why it's recommended for new users. The second way is Gorilla REPL. The Gorilla REPL is very similar to a Jupyter notebook that we use for Python. The pros for this method is that you can save your strategies in a Clojure notebook, and also from my own personal experience, it's more intuitive to use. We will now talk about how to use them one by one. First, we have line REPL. If you want to execute Clojure programs, you can simply copy the link of the GitHub repository and clone it. And decompress it on your local drive. Once it's done, you can change your directory to Clojure backtesting folder and run the command line REPL in the terminal. The REPL is an interactive shell for Clojure, and something similar exists for Python as well. The Lineagen REPL takes a while to compile and start, and usually it takes a few seconds. But if this is your very first time running the command, it'll take longer as it needs to download all the dependencies from the internet. After the REPL starts, the output will be like this. From here, you can type whatever Clojure code you want, and the REPL will execute it for you. Here are a few example statements. Alright, once you're done playing around with the line REPL, you can simply exit it by hitting Ctrl-D or typing exit. Let's try the second way, the Gorilla REPL. To start it, we just need to type the command line gorilla. It'll take a couple of seconds, and you'll finally see the output like this. A link will be provided to you. Simply copy-paste the link into a browser, or you can also command-click or control-click it. Once you open the website, you'll see this piece of text. Gorilla REPL is very feature-rich, and you can access all its functionalities from the menu. Hit Ctrl-G twice to see all the provided functions, and hit Shift-Enter to basically execute all the lines of text and code. You can start coding right away. Here are a few example lines. It is very similar to the Jupyter notebook that you use in Python. If you want to get more information about the Gorilla REPL, I highly recommend that you check out the official website at gorillarepl.org. If you are new to Clojure, we highly recommend that you take some time to go through the tutorials listed on the backtesting website. You can find the link from the GitHub repository. It's under Get Started. These beginner tutorials will help you get up to speed with Clojure syntax and writing programs in this language. Clojure by example lets you write real code and see its output. In case you face any difficulty using the backtester, feel free to post it on the issues page of the GitHub repository. We highly value your feedback and are always looking forward to improving it. Now, I would like to do a code walkthrough with you. For this part, I want to run one of our examples on Gorilla REPL, and through this example, I will briefly talk about how closure backtesting works. The name of this example is Simple Trading Strategy, and you can find it under the examples folder. First of all, when you start writing or developing on the backtester, please first import all the necessary libraries in the backtesting library. After importing them, you can import the dataset that we use. This line is to load the dataset that includes all the information for the stock market in the USA during 1972 till 2017. Here, please remember to replace this line of code with the actual path or the relative path to the dataset on your computer. More information about the dataset can be found later in the introduction of our website. After we execute the code, it will return the range of the dates of our dataset. Moving on, we should call the function initPortfolio. This function is used to initialize the start position. The first argument is the date, and the second argument is the starting balance. Here's one thing that I would like to emphasize. Sometimes you will find that the output of the code state will be a little different from the argument that you input. That is because in the real stock market, the market stops on weekends and holidays. So does the dataset. Therefore, for this function, we will pick the nearest date existing in our dataset as the output. Over here, we meet the first important element in our backtesting, the date. The backtesting is used to simulate real-world trading situations. Therefore, there's a date pointer in the platform that times the global clock of the system. Users can move forward through time and cannot go back. Also, users have access to only market information till today, not the future. So for this line of code, all the evaluation and order you make is rooted on this date. After you state your initial position, you can check which securities are available to trade on that day. They are identified by their perm number. Calling the function available_perm_nose returns a long list of all available perm numbers that you can trade. Then we finally come to the strategy. I'll briefly explain the strategy we're using in this example. I will be trading over the time span of 10 days. I will be buying 50 stocks of some perm note on the first day and then proceed to sell 10 stocks of it every other day. But before we jump into the trading part, I want to talk about the trading logic of the whole backtesting. In our backtesting framework, every order will not be traded immediately. Instead, it will result in a pending order which will be settled by the backtester on the next call of the function next date. What you will observe is that your portfolio will not change immediately after you place an order, and the order record will also not be updated immediately. They will only be updated on the next day. So when you look at the output of the strategy, you will understand why we place the order on the first day, but the record appears on the second day. I'd like to quickly explain the code behind the strategy. So to implement the simple trading strategy we talked about over here, we can use this line of code. So first, we need to define the time span. We can do that with this line of code. We can define a variable called num of days, which is an atomic number equal to 10. The reason it's an atom is so that all changes made to it are reflected across the program. To start the 10 days of trading, we can use a while loop. So while this counter number of days is positive, which is what this expression calculates, we'll be executing this block of code. So if it's the very first day when number of days is equal to 10, we'll place an order for 50 stocks of that security. The function order also takes an optional argument called print. This basically tells that function that it wants to print the order out to the console. So you'll be getting this output. So once this is done, we'll go over here. We'll update the eval report to update the evaluation metrics every day. And this is the important bit. Make sure you call the function next date so that the global clock knows to update the day. At the end, make sure to decrease number of days by 1 by using the function dec. So this loop will run 10 times, and if the number of days is odd, which is every other day, we'll be selling 10 stocks of that security and also output it to the console. Then again, we will update the eval report and move the counter to the next day, and finally decrease the counter. So this will run 10 times and do our strategy for us. And you will get this output at the end. The current date, the date of the orders, and it helps you verify that your orders and your program are correct. After you finish placing all the orders, it is very necessary to use the line at the end to end the order. It helps us deal with all the remaining shares of the stocks we bought and sell them at the current price. So that way you can compare the amount of money you had initially and the money you got at the end to see whether your strategy works or not. But in our strategy, we sold all the stocks that we bought, so this line would not affect the output. The rest of the example showcases various ways of printing data about the orders you placed. There are functions like print order record, print portfolio record, etc. All of these functions take an optional positive number. If you input nothing, it'll print all the records. Otherwise, if you print a number n, it'll print only the first n lines. You can also look into the details about them in the evaluation part over here. In the end, we come to the plotting part. Simply use the plot function to print all the data that you need. We hope that this will help you get started with backtesting. Oz will help you visualize all your data in a really pretty fashion. After the code example, we will give some learning tips about how to get familiar with our backtester. I firmly recommend that you follow this order to learn. Here's something that I would like to further elaborate on. First is the dataset you can find in the user guide. CRISP is the official dataset for the backtester. New users are recommended to directly use this dataset to try out its functionalities. Because even though the backtester supports other datasets, the datasets need to be processed by a specific script in order to be compatible with the backtester. So to reduce the overhead you may have, just simply use the CRISP dataset. The CRISP dataset ranges from 1972 till 2017. Now I'll give you a brief overview about the dataset. The CRISP dataset is a CSV dataset, which has multiple columns, but a couple of necessary ones are PRC, which indicates the closing price, open PRC, which indicates the opening price, the date, which is intuitively the date of the record, and perm number, which is the security identifier. In the backtester, as well as in the real stock market, you should know that we trade on securities. The perm no actually indicates a unique code. Also, APRC is generated by us, indicating the adjusted close price. The actual parameter add APRC is used to add this column to the dataset. So these two lines load the dataset into the program. Next up is our API documentation. Our API is divided by functions. The basic API is used to interact with the backtester, for example, load dataset, placing orders, and so on. The other part of the API focuses on how to manage portfolio, how to evaluate stuff, how to calculate indicators, how to change some predefined parameters, etc. Regarding the indicators, our backtester also provides some functions to calculate the common indicators in the stock market, such as moving average, moving standard deviation, EMA, MACD, ROC, etc. All these indicators will help you to analyze the stock market and make the right decision. Finally, we come to the examples archive. In this video, we only walk through the simple trading strategy. There are also some other very good examples, such as plotting frame and fundamental analysis. We hope these examples can help you get familiar with closure backtesting really quick. Once again, if you found any difficulties using our backtesting framework, do not hesitate to drop your issues down in the official GitHub repository. We really appreciate your response, and we're always looking forward to helping you. Okay, that's all for today's introduction. We hope you enjoyed this video and find our framework useful. Thank you so much for watching.